Hi, my name is Ann Dixon, and I'll be answering the exam questions for Exam 1, Part 2 for Statistics 210, Section 220. I've written my answers on a separate sheet of paper, so I'll be reading them off of that, just so that I don't make any mistakes while I tell you the answers. I will begin with Exhibit 1, Part A. The scientists in this experiment made a mathematical error, and it does not beat 600 million times per year. It meets, when rounded, about 60 million times per year. And so this is just a simple mathematical error made by the scientist, and it's something that we have to be really careful at when we look at statistical information to make sure that there wasn't a mathematical error, and that's what the slippery evidence is called, a mathematical error. For Part B, I'm reading the question, I'm sorry. So, slippery evidence can cause us to make wrong inferences, and as humans, we tend to draw conclusions on a very general basis, and we don't actually check into it or look deeper and see if the science behind it is correct, and therefore, if we don't, we'll just make a quick inference, and a lot of times it can be wrong. Part C, this experimenter, although he did set up some sort of experiment, it wasn't really a controlled, randomized experiment, and he still had no way of quantifying like exactly how much each person ate of fast food and how that really related to the person's heart rate. And he didn't check for lurking variables like past medical history, how much exercise the person did daily, predisposition to heart problems, and all of these things can confound the experiment and cause problems with actually looking at the correct heart rate. For Exhibit 2, Part A, correlation is described as a straight line, whether it's positive, negative, showing the relationship between a variable. It is visible. If it goes up and to the right, it's positive, and if it goes down and to the right, it's negative. And causation occurs when one variable directly affects another, and the causation can only be found through an experiment. The correlation coefficient is a numerical measure of a straight line association, and it's either between -1 or 1, and I have pictures. They'll be, I guess they'll be backwards for you, but so this one right here is a negative association, and so therefore its correlation coefficient would be -1, and this one right here would be a positive association, even though I guess to you it looks like a negative because it's flipped through the camera, but if it's positive, it would have a correlation coefficient of 1. And then this one, there's no correlation, and therefore its correlation coefficient is 0. For Part C, street lights and the sun going down show an association, but there's no causal relationship. And for Part D, the number of kids you have and the amount of money you spend on diapers is an association that does show a causal relationship. And for Part E, I said that it is important to understand the difference between causation and correlation to be able to make better inferences and understand when lurking variables are confounding our data and when they are not. Thank you.